In 1942, British engineers were given an unusual requirement: build a firearm that could fire and barely be heard. On paper, it looked like just another pistol. But during testing, something unexpected happened. The weapon discharged, and the surrounding area remained almost silent. And that's where the real mystery begins. Because this wasn't designed for the battlefield. It was built for close-range, covert elimination, where noise meant failure. Now, so how did they achieve such extreme silence? Why was the design so strangely different? And why have many modern suppressed pistols still failed to fully replicate it? Midway through this video, we'll break down the hidden mechanism, and by the end, you'll understand why the Welrod became one of the quietest assassination weapons ever engineered. In 1942, SOE required silent firearm capability. Standard pistols exceeded acceptable acoustic thresholds. British ordnance evaluated suppressed handgun concepts. Most early prototypes retained semi-automatic cycling. Mechanical slide noise compromised concealment objectives. SOE specified manually operated action requirement. Station 9 initiated controlled development program. Primary designer William Godfray supervised engineering. Prototype designation assigned as 9mm hand firing device. Later nomenclature standardized as Welrod pistol. Design prioritized minimal reciprocating components. Receiver machined from seamless steel tubing. Overall length measured approximately 310 millimeters. Barrel length measured roughly 95 millimeters. Integral suppressor extended beyond barrel assembly. Suppressor body welded to receiver tube. Internal baffle stack utilized aluminum spacers. Early models incorporated rubber wipe discs. Wipes reduced muzzle gas release velocity. Gas containment minimized acoustic signature. Bolt mechanism operated through manual rotation. Locking achieved by interrupted thread engagement. Bolt handle projected laterally from receiver. Firing pin integrated within bolt body. Spring compression occurred during manual cocking. Trigger assembly simplified to single-stage mechanism. No external safety lever was fitted. Grip formed from detachable tubular magazine housing. Magazine capacity limited to 8 cartridges. Chambering standardized for 9x19mm parabellum. Alternative variant chambered in .32 ACP. Magazine insertion formed primary hand grip. Grip panels absent in initial production batches. Ergonomic refinement was not prioritized. Sound suppression exceeded contemporary standards. Recorded discharge measured below 75 decibels. Mechanical noise limited to firing pin impact. Absence of slide eliminated ejection noise. Spent cartridge extraction required manual bolt cycling. Ejection port positioned on right receiver side. Extractor claw machined from hardened steel. Bolt face recessed for cartridge head support. Chamber tolerances specified to tight dimensions. Ammunition selection required subsonic velocity. Supersonic rounds compromised suppression efficiency. Barrel rifling followed conventional land profile. Twist rate optimized for 9mm projectile stability. Front sight blade welded to suppressor tube. Rear sight notch milled into receiver body. Sight radius measured under 150 millimeters. Accuracy acceptable within 15-meter range. Intended engagement distance limited to close proximity. Weapon weight approached 1.1 kilograms unloaded. Mass distribution favored suppressor forward section. Balance reduced muzzle climb during discharge. Manufacturing assigned to Birmingham Small Arms facilities. Production also conducted by ROF Enfield workshops. Machining required precision lathe operations. Suppressor tubes cut from carbon steel stock. Well seams inspected under magnification. Baffle alignment verified using gauge rods. Rubber wipes sourced from industrial gasket suppliers. Wipe lifespan averaged 15 discharges. Field replacement of wipes required partial disassembly. Maintenance instructions issued under classified appendix. Serial numbers stamped on receiver underside. Markings intentionally minimized for deniability. Finish applied as matte black oxide coating. Surface treatment reduced reflective signature. Packaging conducted in unmarked wooden crates. Units shipped via special duties logistics routes. Distribution prioritized occupied European networks. Operational testing conducted at Hertfordshire ranges. Acoustic measurement performed with calibrated meters. Comparative trials included suppressed Colt pistols. Welrod demonstrated superior noise attenuation. Reliability testing involved mud immersion cycles. Manual action resisted fouling accumulation. Suppressed gas residue accumulated within baffles. Routine cleaning mandated after limited firings. A bolt handle occasionally snagged on clothing. Grip angle criticized in internal reports. Magazine spring tension required periodic adjustment. Feeding issues noted with worn magazines. Engineering revisions altered feed lip geometry. Later production improved cartridge alignment. Trigger pull averaged 6 pounds pressure. Trigger linkage machined from stamped steel strip. Internal tolerances maintained through gauge inspection. Reject rates averaged 8%. Primary rejection cause involved suppressor misalignment. Quality control logs archived under SOE authority. Procurement budgets categorized under clandestine allocations. Accounting records omitted explicit weapon references. Transport documentation listed mechanical components. Training manuals restricted to designated operatives. Instruction emphasized contact shot methodology. Barrel often pressed directly against target. Contact discharge further reduced audible signature. Operational doctrine discouraged extended engagements. Slow rate of fire considered acceptable limitation. Manual cycling required deliberate bolt manipulation. Time between shots averaged 3 seconds. Weapon unsuitable for dynamic firefights. Design intent centered on singular elimination tasks. Field feedback collected from resistance groups. Reports cited effective elimination of sentries. Agents valued minimal report during urban missions. Some units experienced suppressor wipe degradation. Cold temperatures stiffened rubber components. Performance variance recorded in winter climates. Engineering staff evaluated alternative wipe compounds. Synthetic materials unavailable in sufficient quantity. Wartime shortages constrained experimentation. Metallurgical inspections monitored barrel wear. Subsonic ammunition reduced rifling erosion. Barrel lifespan exceeded projected estimates. Bolt head hardness measured Rockwell scale 45. Heat treatment conducted in controlled furnaces. Dimensional checks performed using micrometer gauges. Receiver concentricity maintained within tight tolerance. Suppression chamber volume calculated through gas modeling. Internal expansion chambers spaced at fixed intervals. Gas redirection reduced pressure at muzzle exit. Acoustic signature compared against ambient rural noise. Welrod discharge approximated hand clap intensity. Testing documented reduced echo propagation. Urban brick environments slightly amplified report. Operational planning considered environmental acoustics. Weapon storage required dry internal conditions. Moisture compromised rubber wipe integrity. Agents issued spare wipe kits. Instruction sheets printed on thin rice paper. Disposal procedures included component separation. Capture risk prompted self-destruction guidance. Some units destroyed through explosive charge attachment. Production totals estimated at several thousand units. Exact numbers remain partially classified. Post-war inventory audits identified surplus stocks. Certain units transferred to intelligence services. Later evaluation conducted by military historians. Firearms specialists measured residual suppressor efficiency. Aging wipes reduced acoustic performance. Museum specimens often lack original components. Civilian legal restrictions later prohibited possession. Classification persisted into late 20th century. Comparative studies referenced Welrod in design analysis. Modern suppressor pistols adopt semi-automatic mechanisms. Few replicate full manual bolt configuration. Welrod remains benchmark for suppressed simplicity. Engineering prioritized noise elimination over ergonomics. Grip discomfort documented in internal memoranda. Balance considerations secondary to suppression efficiency. Bolt rotation angle measured approximately 90 degrees. Locking lugs engaged receiver recesses securely. Chamber support prevented case rupture incidents. Proof testing utilized overpressure cartridges. No catastrophic failures recorded in trials. Suppressor cleaning required solvent immersion. Carbon buildup affected internal volume. Field improvisation sometimes replaced worn wipes. Improvised materials degraded suppression reliability. Official guidance discouraged unauthorized modification. Weapon intended for covert elimination roles. Operational secrecy defined entire development process. Documentation circulated under restricted clearance. Design philosophy reflected clandestine operational needs. Welrod represented focused mechanical reductionism. Every component served acoustic minimization. Purpose. Mechanical complexity intentionally avoided. Service life extended through conservative usage. Rate of issue remained controlled. Withdrawal from service occurred gradually. Surviving examples preserved in limited collections. Engineering legacy persists in suppressed weapon studies.